Hello, I'm Predrag Radenkovic, CTO at codeplane. codeplane is a spec-driven development platform that we've been developing for the last 2 years, and I would be happy to share some details with you today. So with prompt-driven development, basically the coding agents are operating on the code level, maintaining the code and everything, all the decisions that you made are staying in the code, and the prompt is thrown away after that. With spec-driven development, we are raising the level of abstraction one level up, where the agents are operating on the spec level with engineering guiding them through this process. All the decisions stay captured in the specs, and the code is generated based on those specs after that. So when you are developing third-party integrations, you are essentially becoming an expert in those third-party systems, which is something that you usually don't want to focus on. You want to focus on building your product while automating as much of this as possible. So in order to achieve this, we are using agents that are already really good at understanding third-party APIs, validating the documentation, and writing those intents into the code or specs. Where the specs are actually better or thriving in comparison to code is maintaining of these integrations. Especially if you are doing integrations at scale, when you have to maintain majority of by statistics, somewhere around 5 to 10% of integrations are broken every month, and this is the time that you are spending fixing things that you cannot control completely. And with specs, those changes are boiled down to some really minor changes in the specs that you only after that review, and the rest is fully automated. Good specifications are first of all precise. They are broken down into reasonable chunks, and they are very structured. On the top of that, they should not contain any ambiguities or conflicts. Writing good specs is hard. We at codeplane developed a plain language, which is a structured way how you write the specifications, and have all the good practices that we have in the industry developed for decades. So it follows the precision, modularity, reusability. You can structure your specs into multiple parts. Writing this is hard. We developed an agentic framework that actually guides engineers through writing their intent into specs. With this framework, engineers are asked to make the crucial decisions, and those are then captured into the specs. After that, engineers simply review them. After the specs are written, you are reviewing the specs, and with that, you are already doing a lot. Especially if those are structured specs, and the implementation after that is completely based on that structure. Once you as engineer are comfortable and confident in the specs that you wrote, you are letting them through our code agent, who is implementing those specs, but moreover, they are automatically validating them. And they are doing this through a different set of conformance tests that are completely written based on the specs, but executed on the top of the code that was implemented. So basically, with that approach, you have a double check. Most of those tests are completely black box end-to-end tests. So what you get in the end is fully tested software against the third-party APIs, and you are confident to, start manual testing. So with structured specs, there are many good things that are coming out of that. So the first one is that you can maintain them properly, and this is the crucial part. Regarding software development, it was never about building something but maintaining it in a long run in production. And structure specs are actually giving you this. Treating the specs as the only source of truth is actually really approach that you want to go with this kind of systems where the code can be properly validated. Yeah, that is a very valid question, and that's why we at codeplane, we are developing this spec-driven development platform to be widely used. But we are approaching it at the same time very carefully and picking the right verticals to which the current technology can be applied with confidence. Why we picked, for example, integrations as one of the verticals that are good is because integrations can be validated completely end-to-end and all the edge cases. What we, for example, avoid at this moment with spec-driven development is user interface development, because validating of user interface is way more complex and it requires a lot of additional development. So we see this something on a horizon, but we are approaching this with other smaller verticals like scraper development, ETLs and things like that are easier to be validated.